Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
So in this way, you can do all this type of configuration. So this is done now, conditional route advertisement as well as conditional route injection. So again, everything is in its default state once again. And now next topic is going to be related to migration now in BGP. Related to migration. Let's assume that New York router, and behind this New York router you are having multiple routers. Are you getting my point? New York router as well as behind New York router, all routers. I mean, at New York site you are using AS8127. Are you getting my point or not? We are also assuming that you are also having some other prefixes behind New York router. I mean, like router 10, 15, something like that, and all of them are having IBGP neighborship with each other, right? And then finally, New York router is advertising all these prefixes in the direction of BT. And also, what will I do? I will move on R1. I'll create one loopback. I can take. I think loopback 1 is not there. Let me see. Yes, loopback 1, 100.1.1, loopback 2, loopback 3, router BGP, it's using 65500, network 100.1.0, mask, swipe BGP. You will also see other prefixes sooner, because the minimum time interval in between two consecutive advertisement is what? 30 seconds. See. Understood? Fine. Now BT on BT, actually your remote AS is configured as 8127, but you are doing some migration now, and now you want to configure AS 8000 in place of 8127 within this site. Within this site, have you understood it or not? Now you will ask to your service provider BT that, okay, do one thing, change my remote AS. BT will say that, okay, I'll do that according to my SLA, service level agreement. Are you getting my point or not? So BT can ask you to take like 24 hours, for sometimes 48 hours, or sometimes like 72 hours. It will be depending on the agreement in between you and your service provider. Fine, guys. So now you cannot wait for BT's configuration, right? You decided that, okay, I'm going to update my own AS. So new router, they said no router BGP 8127, and now they configure router BGP 8000. Router BGP 8000, sorry, router BGP 8000, and then they said neighbor 101.1, sorry, I think it was using 80, right? 80.1.1. Remote AS is what? Now it will start to give you an error message of wrong peer AS, something like that. It will start to give you notification message, right? Peer in wrong AS. Of course, it will show you, because over there we configured remote AS as 8127, and right now I'm using here 8000. So of course, ASs will mismatched and neighborship will never come up. How can you solve this problem now? To solve this problem, what can we do? We can configure multiple AS on a single router. Like right now, what is running here? AS 8000. Along with this, because I know very well that for BT I'm still using 8127, so I can also configure 8127 on at my own end for this particular neighbor only. For doing that, you just need to say this command as well, name 80.1.1 local AS is what? 8127. What does it mean? That for this particular neighbor I will start to use AS 8127, not 8000. So in this condition only we can say that in BGP it is also possible to configure more than one AS onto a single router. You see? Now it will start to use this 8127 for this particular neighbor. However, we are running only 8000. Are you getting my point or not? So this is the uses of local AS command in BGP. Now neighborship must come up. It have stopped to give you notification messages, so definitely neighborship will come up. And now you see, show IP BGP. I mean, let me do one thing. Router BGP 8000 and then redistribute connected, so that it will also start to advertise its own prefixes towards that particular neighbor, right? Show IP BGP, check it out. So it is receiving all prefixes coming from there, and also it have started to advertise its own prefixes towards. Are you getting my point or not? Yes. Try to understand now. But the problem is, see, in all incoming prefixes, what is happening? What is this? 8127 has been prepended in all incoming prefixes without any reason. However, this New York router is receiving these prefixes coming from directly BT, but see, 8127 has been prepended because we are also running this 8127 now in between this New York router and BT. Is not it? We configured it with using local AS keyword, and due to this prependation of this AS of this 8127, what will happen? Let's say that New York router is having some IBGP neighbors in 8127 itself. Let's say that on those routers you have not applied AS 8000 yet. You are still running 8127. Are you getting my point or not? Yes. Let's say your downstream routers are still using AS 8127. Now, will it be possible for those routers to receive all these prefixes now? Hello? Let's say, as I earlier said, that in your site you are having multiple routers, they are running IBGP, right? So onto those downstream routers still you are using AS 8127. So you can also use local AS keyword for them as well, right? Hello, to your downstream routers as well. So whenever this New York router, I mean this edge router will advertise these prefixes 100.1.0/24, 100.1.2.0/24, 3.0/24 towards those routers, will it be possible for them to receive these prefixes? No, because they will think that they have already crossed their AS 8127, is not it? So how will you solve this problem? To solve this problem on New York router, what can we say? Router BGP 8000, and for this neighbor, as I said, local AS, I can also say no prepend. With using this keyword, it will start to stop prepend this AS 8127 in all incoming updates. But it will impact only and only incoming updates, right? Are you getting my point or not? So if any update is coming from BT towards this AS now, it will not prepend 8127. Let me show you. Show IP BGP. See, 8127 is not there now. It means now in case if New York router, I mean this edge router is advertising these prefixes towards downstream routers which are still using AS8127 will also start to accept, will also start to receive all these prefixes. Piyush, are you okay with this or not? So this is the uses of no prepend. But remember, this no prepend keyword will work only for incoming prefixes. And see, now go back to BT and on BT check that which prefixes have been advertised from New York to BT. See, all these prefixes are coming. And what is happening? See, it is prepending 8000 as well as 8127. However, for BT we are running only and only 8127. If BT has configured this command that it must receive these prefixes from AS8127 only, not from any other AS, then BT will start to discard all these incoming prefixes coming from New York router, is not it? So to solve this problem, now you do one thing, move back again on BT, move back again on New York router, and as you configure your no prepend command, no router BGP 8000, along with that you can also say replace AS. This replace AS keyword will enforce this BGP to prepend that AS information only in its outgoing updates which is actually running for that particular neighbor, So right now it is prepending 8000 as well as 8127, but right now for BT we are running 8127 only. So after using this replace AS keyword, you will see that it will start to prepend only and only 8127 in all outgoing updates. So this replace AS will work for outgoing updates, whereas no prepend keyword will work for incoming updates. So move back again on BT and check its BGP table now. Only 8127. There is nothing like 8000. And now there is a little problem now. Let's say BT have changed now its remote AS from 8127 to 8000. Again its neighborship will go down. And again you have to remove that local AS keyword from there, right? So it can cause a problem. To solve this problem, what can we do? We can do one thing. After replace AS, we can also use this keyword dual AS. So it will happen that this New York router will start to use both ASs for this particular neighbor 8127 as well as 8000. So if neighbor is coming with AS 8127, then also it will form neighborship. If if BT is coming here with AS 8000, then also it will form neighborship. And this replace AS and no prepend will also work along with that. So now you will see that neighborship will come up once again. Just wait for a moment, right? It will form neighborship. And then after I will move there on BT and I will change remote AS, and then I will show you that neighborship will come up automatically. It will give you this notification message, don't worry, because right now it is using both ASs. But finally neighborship will come up. You see? Show IP, BGP. Check it out. All prefixes are coming over here. And right now, because we are using 8127, so BT must receive all these prefixes with AS8127 only. See, because we have used replace AS keyword. Now, on BT, I will change its remote AS. In place of 8127, I'll make it 8000 now. I'll show you that we will not require to do any modification at the end of New York router, and neighborship will come up automatically. So router BGP 35500 neighbor 80.1.10 remote AS is what? Do show run pipe section router BGP. Let me show you. Fine. In place of 8127, we have started to use now. See, neighborship have came up. Show IP BGP. Check it out. Now it will start. New York router will start to advertise all those prefixes after prepending only 8000. This is the uses of replace AS keyword. And now you move back again on New York router. Show IP BGP. BGP. Check it out. No prepentation for incoming updates as well. So after dual AS, you do not have any other option. Don't worry about that. So router BGP 8000, and then after dual AS, you do not have anything else. So I hope you people have understood the uses of local AS, no prepend, replace AS, as well as dual AS. So these things will be used in BGP during migration only. If you are not doing migration, then definitely you will never require for doing this type of configuration in BGP. Fine. Okay. This is also done now. After performing these things in BGP, now let's discuss about fast failover. Fast failover. You know, sometimes what happens, let's say that there is a IBGP peering in between R1 and R5. Are you getting my point? With using their loopback addresses, loopback interfaces. And their loopback interfaces are reachable to each other with using IGP, which is OSPF over here. In case from R5, the loopback of R1 becomes unreachable due to OSPF. This BGP will take 180 seconds to break its neighborship. BGP can break neighborship immediately in that case only. Let's say right now New York router has formed a neighborship with BT with using interface FA0x0 IP address itself. If I shut down FA0x0 manually and if its line protocol goes down, then only BGP can break its neighborship immediately. But if you have configured its neighborship with using loopback, it will not work. It will not break its neighborship immediately. Let me show you. If I move on New York router and if I go to its FA0x0 and shut it down, you will see that BGP neighborship will also go down immediately. It has gone down. It will come up once again. Don't worry about that. So in case if your neighbor is directly connected, then if your interface is going down, then BGP peering will go down immediately. If it comes up, it comes. If it comes back up, then definitely neighborship will also come up. You see that neighborship will come up very soon. It is in active state. Still in active state. Let this BGP peering come up and then I'll show you that in case if don't worry about that. Fine. Check it out. Everything is fine. Now in case if the loopback of R1 goes down, then definitely R5 should break its neighborship with R1. Right now R5 is having neighborship, you see. So IP BGP summary. It is having neighborship with R1 and it is receiving 3 prefixes from there. Now you do one thing, move back again on R1, go to loopback 0 and just shut it down. Now move on R5, so IP BGP summary. See, neighborship is still there. It will remain there. However, this neighbor IP address is not reachable. This is completely incorrect. See, is there 150.1.1.1/32? Tell me. This is the problem of BGP. To solve this problem, we are having a feature in BGP which is known as fast failover. You just fast failover, failover, not failover, failover. Yes. Fine. So you do one thing, move back again on R1, say no, shut down, so that it will become reachable from R5 now. Show IP route, you will see that once again it will start, it will become reachable from here, see, via OSPF. Fine guys. So this time I will enable this feature in BGP. To enable this feature, router BGP 65500. First of all, you have to disable this feature, fast BGP fast external failover. Just remove it. This is for interfaces only, right? This is for, like if directly connected interface goes down, then only it will break its neighborship. Fine. Then you do one thing, go to neighbor 150.1.1 and say failover. This is called fast failover. So you are enabling this feature for this particular neighbor only now. After enabling this feature, what will happen, that whenever there will be any change in its RIB, whenever there will be any change in its routing table, it will verify its neighbor reachability. If its neighbor is not reachable, then it will break its neighborship immediately. Are you getting my point or not? So what is the rule behind this failover? That whenever there will be any change in its RIB routing information base, then it will immediately try to verify reachability. It will verify reachability with, tell me,
the name.
have you got it or not? Now do one thing, say debug IP BGP and go back to R1 this time, say shut down, and you see now on R5 I shut down that link on R1. What is happening over here? See, there was a change in its routing table. Even you could say debug IP route as well, so that you could see that there was a change in its routing table. So see, established to ideal, route to peer lost. This is the uses of failover keyword. So it would be good to enable this feature for all IBGP neighbors, because in production networks your IBGP neighbors will always be directly connected and will be reachable through IGPs only. Have you understood it or not? So this is called fast failover. In case if it comes back up, of course neighborship will come up once again. So I hope that you have understood the feature of failover in BGP. Got it or not? For sure? Great. People have start to sleep. Okay, do one thing. Now after it, let's go for soft reconfiguration. Soft reconfiguration.
सर जब फास्ट फॉलोवर में नहीं लिखा हुआ तब भी तो वो चेंज होता ही होगा मतलब.
अब मैं see I tried, I mean without enabling fast follower, I shut down the loopback of R1. We saw that R5 didn't break. Yes. But then after I enabled follower, then I went back to R1, I shut down the loopback of R1, then we saw that R5 immediately broke its neighborship with R1. That was the only uses of follower.
सर मेरा मकसद वही है मैंने कहा क्योंकि वैसे भी उसको पता तो चल ही रहा है
नहीं चल रहा ना, प्रॉब्लम तो यही है, कैसे चल रहा है बताओ। उसको बीजीपी को नहीं पता चल रहा ना, ओएसपीएफ जानता है, बीजीपी नहीं जानता। Because the loopback of R1 from R5 is reachable through OSPF only, not via BGP. So if the loopback of R1 is going down, then it will inform to OSPF only, not to BGP. That is why I said that for R5, I mean, in terms of BGP, in perspective of BGP, there is no change actually. That is why it has to do wait for next 180 seconds. Not exactly 180 seconds, because might be possible that last keep alive it received before 40 seconds, and then after the loopback of R1 went down, then definitely it will break it after 120 seconds only. Or sorry, 140 seconds only. So it will be depending on the conditions. I mean, maximum it will take 180 seconds, but minimum it will take 120 seconds. Just to reduce that timer, we are using here feature of follower. So let's talk about now soft reconfiguration. Have you understood it or not? So if you talk about the soft reconfiguration feature in BGP, see, thing is like, guys, try to understand, like I'm on R1, try BGP, it's receiving all these prefixes from its neighbor. Are you getting my point or not? Hello? Now, if I wanna filter, just try to understand now, I wanna filter 100, do not write anything, right? Just try to understand these things. If I wanna filter 100 and 101, which is coming from R5 as well as R6, I'll require to create, see, I'm covering now filter out filtering with using prefix list as well as soft reconfiguration. Fine. So to filter all these prefixes, we can create one prefix list over here, IP prefix list, IP prefix list, CCIE deny 192.168.100.0/23 greater than equal to 24 and less than equal to is also to allow all others CCIE permit less than equal to done. Then after it, go to router BGP. You have two options, either say distribute list, prefix list. Name is in which direction. So now this time this prefix list will be applied for all neighbors automatically, because you have configured this distribute list globally. So it will be applied for all neighbors. So from any neighbor, if it receives those prefixes, it will filter them. That's what I want actually. Fine, but your changes will not take place. You have to say clear IP BGP star in, so that you will force your neighbors to retransmit updates. And if your neighbor is retransmitting update, it has to give all updates. Let's say you are having 1 lakh prefixes. Your neighbor has to retransmit 1 lakh prefixes every time. This is going to be very, 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 of course, danger for your network actually. Of course, it's dangerous. That's why we say that BGP must be consistent. BGP table must be consistent. Whatever you want to do, just configure it once and then after forget about changes. Generally, we do not like to make changes frequently in BGP. This is the reason. Because every time whenever you will make any change, you will require to ask to your neighbor to retransmit updates, and then definitely your neighbor's CP utilization and your own CP utilization will be higher. Have you understood it or not? And also your bandwidth consumption will be higher. Got it? Fine, guys. To see that okay, your neighbor has to retransmit updates, what can we do? I will move on R5. I will say debug IP BGP updates. I will move on R6 as well. I will say debug IP BGP updates. And then I'll move on R1. Then I'll say clear IP BGP star in R5. What is it saying? Sending update? Is not it? Sending update. Are you getting my point or not? And R6 is also sending updates. To whom? R1. Have you got it or not? Fine, guys. If you do not want to let your neighbors to retransmit updates, and if you want to refresh your BGP table by your own, if you do not want to disturb your neighbors during refreshing your own BGP table, are you getting my point or not? For that purpose, in BGP, you can enable soft reconfiguration in this way. Like you move on R1, once again go to your router mode and remove this distribute list from here. Do clear IP BGP star in once again, so that your BGP table will be having all those prefixes now once again, right? Once again, I want to show you here. So see, run this command as well. So IP BGP 150.1.5.1 received. So IP BGP neighbor 150.1.5.1 received. What is it saying? Now everything is fine. When you have received all prefixes from your neighbor, do one thing. After receiving all prefixes, go to your BGP, router mode, and then say neighbor 150.1.5.1. And it can be configured in one direction only, which is inbound. That's it. Just enable it. In same manner, enable it for. But now there is a problem. Generally, in production network, we do not use these commands. We will be relying on neighbors only. The reason is now there will be two tables after enabling this feature. One table will be for received prefixes and one will be your BGP table. So your memory consumption will be just double. One is this, which is your BGP table, and another one will be show IP BGP neighbor received prefixes. See, from this neighbor as well as from this, you see. So one table is for received prefixes and another table will be for BGP. Another will be BGP table. Now the advantage of configuring this software configuration would be here. Like you do one thing, move back again on R5, just press some enter so that previous log messages will be up. Right now, see, still debugging is enabled on R5 as well as R6. You move on R1 now and configure the distribute list once again. Fine, guys, and again you will see your changes will not take place, but this time say clear IP BGP star soft in. So this time it will not send this request to its neighbor. It will update it from its received prefixes table itself, right? It will not send any route refresh request towards its neighbors. Let me show you. Show IP BGP. So now those I think do one thing, apply it for neighbor 150.1.5.1. say prefix list name was. See, if you are applying it for particular neighbor, then you will not call it under distribute list. You will directly say prefix list. So generally we will be using this feature for route filtering in BGP actually in, and then configure it for 6 as well. And now say and check BGP table. Is it having 100 and 101? And you move back again on R5. Have it shown you any update over here? Any log message? R6, nothing. If you move back again on R1, if you are checking its BGP table, you do not have those prefixes. But if you say received prefixes, you are still having all those prefixes. That's why I said that now memory consumption will be just double. This is the uses of soft reconfiguration. So if you have enabled soft reconfiguration for a neighbor, then you will create a separate table for received prefixes, and you will be having all those prefixes in that table. So if you want to allow anything in your distribute list, in your prefix list, or you deny, it will get refreshed or it will be updated via with the help of that received prefixes table only. It will not require to send a request, route refresh request towards its neighbors.
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.